Good morning, children. We proceed on to exercise 3.5 Non-Polynomial Equations. Question number 1, subdivision 1, solve. We have a trigonometric equation here. Sine square x minus 5 sine x plus 4 equal to 0. To factorize this, let us assume sin x as a new variable, say y. So we are assuming sin x as y. So the given equation becomes sin square y square minus 5 sin x is y plus 4 equal to 0. Factorizing 4, I can say minus 1 minus 4 together giving minus 5. So the factors are y minus 1 into y minus 4 equal to 0, or I get y is equal to 1 comma 4. My question is y equals sin x. Sin x equals to 1 is valid because sin x can take the value only between minus 1 and plus 1. Sin x can take the value between minus 1 and plus 1. So sin x equal to 4 is not valid. So only which answer is valid? Sin x equal to 1. Let us remember the principal value. So we are in trigonometrical equation. When sin x is positive, the principal value alpha I keep positive. When sin x is 1, we recall the principal value as pi by 2. Sin 90 is 1. So 90 we write as pi by 2 radians. And recall the formula, sin theta equals sin alpha. We write the general solution, theta equals n pi plus minus 1 power n alpha. In this question, alpha is pi by 2. Theta is x. So I will write sin x equal to 1 implies the general solution is x is equal to n pi plus minus 1 power n. In the place of alpha, I will write pi by 2. So trigonometrical equations, the solution we have to remember. When sin theta is sin alpha, where alpha is the principal value. I recall the general solution, theta equals n pi plus minus 1 power n alpha. Here theta is x and alpha is pi by 2, and that completes the solution. Question number 1, subsection 2, solve. 12x cube plus 8x equals 29x square minus 4. Bringing them to the same side, it is minus 29x square plus 4 equals 0. Or rewriting the order, 12x cube minus 29x square plus 8x plus 4 equals 0. This is an ordinary cubic equation. They have not given any clues about the roots. So, we have to guess the roots. How to check the roots? If I add all the coefficients, 12 minus 29 plus 8 plus 4. So, if I add all the coefficients, if my answer is 0, I will say 1 is a root of it, but it is not equal to 0. So x is equal to 1 is not a root. So my very first idea, I check all the coefficients added together gives me 0. Here it is not. If it is 0, I will declare x is equal to 1 is a root, but it is not 0. So x is equal to 1 is not a root. Now I check whether odd coefficients. What do I get as odd coefficients? 12 plus 8. and even coefficients. What are the even coefficients? I get minus 29 plus 4. As I find the odd coefficients, 12 plus 8, that is 20. As I find the even coefficient sum, that is minus 29 plus 4, that is minus 25, which is not equal. So I will declare x is equal to minus 1 is not a root. So I have decided 1 and minus 1 are not roots. So the last condition, let me check for 2. So put x is equal to 2 in the given equation. Call the given equation as 1. As I substitute, 12 into 2 cube is 8. Minus 29 into 2 square is 4. Plus 8 into x value 2 plus 4. It is 96 minus 116 plus 16 plus 4. The answer is 0. This declares x is equal to 2 is a root. So given a problem without any clues about the roots, we need to check like this. Adding all the coefficients, giving 0 tells x is equal to 1 is a root. If it is not 0, x is equal to 1 is not a root. Sum of the odd coefficients and sum of the even coefficients, as I check, they are not equal tells me x is equal to minus 1 is also not a root of it. Third chance, let me check x is equal to 2. So by trial and error, we are checking the roots, and fortunately I have identified one root. Once I know a root of the equation, let me go with synthetic division method to identify the quadratic factor. What are the coefficients? 12 minus 29, 8, 4. We have identified 2 as a root. So put 0, 12 plus 0. 2 12s are 24. Minus 29 plus 24 minus 5. 2 into minus 5 minus 10. 8 minus 10 minus 2. 2 into minus 2 minus 4. I have achieved 0. Now with this I multiply x square. With this I multiply x, and this I will call the constant. So how to write the quadratic factor? Once I identify, I will write 12x square minus 5x minus 2 equal to 0. Let us solve this. 12 into minus 2 minus 24, and I need minus 5. What are the two numbers? It is 8 3s are. Because I have minus, it is minus 8 plus 3. So what are the factors? Here it is 12x square. So we divide by 12x. As I simplify, 8 and 12, as I cancel, it is 12x minus 8. Or as I cancel, I will get 4 table cancelling, 3x minus 2. Similarly here, 12x plus 3. As I cancel 3 table, I get 4x plus 1. So we have the two factors, 3x minus 2 into 4x plus 1 equal to 0. Or 3x minus 2, 0. X is equal to 2 by 3. 4x plus 1, 0. X is equal to minus 1 by 4. So we have arrived at the 3 roots. It is a cubic equation. When the power is 3, we have the 3 roots. So what are the 3 roots? It is 2, 2 by 3 minus 1 by 4. Exercise 3.5, question number 2. Examine the rational roots of the given equations. To examine rational roots, we are going to use rational root theorem. What does it mean here? Call this as A0 and call this term, the highest term, the coefficient I call an. What are the factors of A0 I have to write? So that I call P. So what is P? Possible factors of A0. What are the possible factors of A0? Here A0 is -1. What all can divide? I can say either +1 or -1. Now what is Q? We call possible factors of AN. AN is 2. What could be the possible factors of 2? Again, it could be ±1 or ±2. Now what we need to find out is P by Q. What is P by Q? 1 by 1. So it could be either ±1 or 1 by 2. So it could be either ±1 by 2. So if suppose there are rational roots, it can be any of these values. Let us check it. What is the function given to us? 2x cube minus x square minus 1 equal to 0. Check whether 1 satisfies. So if I call the given expression as P of x, wherever x comes, let me put 1. Check whether 0 comes. If I put 1, 2 into 1 cube minus 1 square minus 1. It is 2 minus 1 minus 1, 0. So I will declare 1 is a root. So 1 root I have identified. Now let me check with the other root, say -1. So what is P of -1? 2 into, wherever x comes, put -1, the whole cube, minus, wherever x comes, I put -1, the whole square, and -1. -1, the whole cube is -1. -1 into 2 is -2. -1, the whole square is +1. +1 into -1 is -1. Again I have -1. This is not equal to 0. That tells me -1 is not a root. So we have identified +1 as a root because I arrive at 0, the RHS. But -1 does not give me 0. So I can immediately say -1 is not a root. Now let me check. Half. Wherever x comes, I am going to put half. P of 1 by 2. So wherever x is coming, we are going to put half. 2 into 1 by 2, the whole cube, minus 1 by 2, the whole square, minus 1. It is 2. 1 by 2 cube is 1 by 2 into 2 into 2, that is 8. It is 1 by 8. Minus 1 by 2 square is 1 by 4 minus 1. Obviously, this is not equal to 0 because this is 1 by 4 minus 1 by 4. My actual checking is only 0. This is not 0. So, I will say 1 by 2 is not a root. Similarly, let me check minus 1 by 2. So, we had 4 options. +1, -1, plus half and minus half. Again in this equation 2 into minus 1 by 2 cube minus -1 by 2 square minus 1. As I simplify, 2 into minus cube is minus, 1 cube is 1, 2 cube is again 8. Minus square is plus. So minus 1 square is 1, 2 square is 4. Minus 1. If I cancel, it is minus 1 by 4, minus 1 by 4, minus 1. Again, my answer is not 0. Therefore, I will say minus 1 by 2 is not a root. So the only possible rational root is 1. Let me check this by synthetic division. So if I use synthetic division method, the given equation is 2x cubed minus x squared. There is no x term. Let us put 0x minus 1 equal to 0. If I put the coefficients 2, minus 1, 0, minus 1. And we have arrived at 1 as a root. So let me put 1 here. 0. 2 plus 0, 2. 1 2s are 2. 2 minus 1 is 1. 1 1s are 1. 0 plus 1 is 1. 1 1s are 1, which gives me 0. Obviously, 1 is a root. So we have identified using rational root theorem. We have also cross-verified using the synthetic division method. Now what is the quadratic factor I get from this? I will say it is 2x squared plus x plus 1 equal to 0. Just by looking I know it is plus 2. So b square minus 4ac. I will have 1 minus 4 into 2 into 1 is 8. It is below 0. Whenever the discriminant is below 0, we will declare the roots are imaginary. My question is only the rational root. So we arrive at 1 is the rational root for this particular question. So using rational root theorem, which says call the constant as a0, call the highest term coefficient as an. Write the possible factors of a0, call them as p. Possible factors of an, call them as q. Find out p by q. That gives rise to plus or minus 1, plus or minus 1 by 2. And the given factor, let me call p of x. Checking each value, I am able to show 1 is a root which is rational. Obviously, by synthetic division method, I get the quadratic factor and the roots are imaginary. Second subdivision, x power 8 minus 3x plus 1 equal to 0. Again, we are using rational root theorem. So, rational root theorem, as I apply, I call the last constant as a0 and the highest power term, that is x power 8, and the coefficient I call as an. Now we need to write the possible factors of a0 and an, call them as p and q. So what is p? The possible factors of a0. Here a0 is 1. So what are the possible factors of 1? It is plus or minus 1. And q, I call the possible factors of an. What is an here? That is also 1. I get plus or minus 1. Now I need to find out what is p by q. Obviously, p by q is plus or minus 1 by plus or minus 1. It is again plus or minus 1. So let us call the given polynomial as p of x. That is x power 8 minus 3x plus 1. So what is p of 1? 1 power 8 minus 3 into 1 plus 1. It is 1 minus 3 plus 1, which is not equal to 0. So I will declare 1 is not a root of this equation. Check for minus 1. The second answer is minus 1. It is minus 1 power 8 minus 3 into minus 1 plus 1. That is minus 1 power 8. Whenever negative power positive, that is even number, is coming, minus 1 power 8 is obviously plus 1. Minus 3 into minus 1 is plus 3. Again I have plus 1. This is also not equal to 0. So I will declare minus 1 is not a root. So we had only two options, plus 1 or minus 1, and I am able to verify both are not roots. So we will declare there are no rational roots for this particular equation. And that completes our answer. Exercise 3.5, question number 3. Solve 8x power 3 by 2n minus 8x power minus 3 by 2n equals 63. The problem may look so difficult, but it is not so. Here the power is 3 by 2n. Here the same term but with negative symbol. So how shall we rewrite this? I can write it as 8x power 3 by 2n minus 8. Bring this negative power to the denominator, it becomes positive, equals 63. Now, this term, something that is difficult to be, let me give a new name, say y. So, put y equals x power 3 by 2n. As I substitute, I get 8y minus 8 by y, and bring 63 through the left, it is minus 63 equals 0. As we cross multiply, 8y into y minus 8 minus 63y equals y into 0, 0. Rewriting the equation in the proper format, 8y squared minus 63y minus 8 equals 0. As I try to factorize, I have 8 into minus 8, I get minus 64, and I want minus 63. What are the two factors? It is 64 into 1, but I want minus 63. So put minus 64 plus 1. Now, the first term is 8y. So I will write by 8y by 8y. As I cancel, it is y minus 8 into 8y plus 1 equals 0. Or we get y equals 8, y equals minus 1 by 8. Now what is x term given in the question? Y equals x power 3 by 2n. So what is y here? 8. So I will put x power 3 by 2n equals 8. X power 3 by 2n equals 8. So this side 3 by 2n I can bring to the other side as 8 power 3 by 2n comes as 2n by 3. How to rewrite 8? I can write it as 2 power 3. We know 2 into 2 into 2 is 8. So 8 can be written as 2 power 3, the whole power 2n by 3. I can cancel 3 and 3. So x is equal to 2 power 2n. Or I can say 2 power 2, the whole power n. So we can always say this answer as 2 square as 4 power n. So I can tell x is equal to 2 power 2n, or I can say x is equal to 4 power n. The second option, y equals minus 1 by 8. So x power 3 by 2n can also be minus 1 by 8. Actually, this need not be done. We will arrive at the same answer only. Anyway, let us try and complete it. So what is x? Bringing 3 by 2n to the other side, I will get minus 1 by 8, the whole power 2n by 3. This side power 3 by 2n will come to the other side as 2n by 3. This is minus 1 by 8 can be written as 2 power 3. The whole power 2n by 3. Obviously, this 3 and 3 I can cancel. So we get x is equal to minus 1 by 2 the whole power 2n. Reciprocating, I can write minus 2 the whole power. When I reciprocate, power will become negative. Either I can leave the answer like this. If you substitute x as 4 power n, the equation gets satisfied. If you substitute x as minus 2 power minus 2n, also the equation gets satisfied. Or I can still rewrite this as minus 2 the whole power 2 is 4 the whole power minus n. Minus 2 the whole square is 4 the whole power minus n. Here it is 4 power n, here it is 4 power minus n. Do we need to say plus n minus n? Nothing is mentioned in the question as to what is n. So n can be either positive or negative. So combining both, I can simply say the solution as x is equal to 4 power n. N can be either positive or negative. Exercise 3.5, question number 4, solve. 2 root of x by a plus 3 root of a by x equals b by a plus 6a by b. As I look at the question, I have x by a, whereas here a by x. So these are reciprocals. So we can put a substitution for these two as y equals root of x by a. Naturally, 1 by y will be the reciprocal root of a by x. So this we shall substitute in equation number 1. We get 2y plus 3 into 1 by y equals b by a plus 6a by b. As we cross multiply with y, we get 2y squared plus 3 equals b by a plus 6a by b into y. As I bring to the left, I get 2y squared minus b by a plus 6a by b into y plus 3 equals 0. As we need to factorize, let us remember 2 into 3, I put 6 and I want minus b by a plus 6a by b. Obviously, these two are the factors. Check. If I multiply, here I put minus b by a, here I put minus 6a by b. Just check whether my answer is right. As I add, I get this. Minus into minus plus, b by a by b cancels, I get 6. So, the two factors are minus b by a minus 6a by b only. And here I have 2y squared. So, I will divide by 2y. And as I simplify, it is 2ay minus b. 2ay minus b, first factor, into 2by minus 6a. 2by minus 6a. 2ay minus b. 2by minus 6a equal to 0. As we check, 2ay minus b 0 or 2ay equals b, y equals b by 2a. The second factor, 2by minus 6a is 0. 2by equals 6a or y is equal to 6a by 2b, cancelling 2, it is 3a by b. So we have arrived at the two answers for y. But what is y? It is root of x by a. So I will say root of x by a is b by 2a, or root of x by a is 3a by b. As we square, I get x by a equals b square by 4a square. Cancelling one a, we get x is equal to b square by 4a. Another answer, x by a equals 9a square by b square. So squaring this, I get b square by 4a square. Squaring this, I get 9a square by b square. As I cross multiply, x is equal to 9 a into a square, a cube divided by b square. So we have solved the given equation and we have arrived at the two answers. X is equal to b square by 4a or 9a cube by b square, and that completes the solution.